let's quickly start. So the goal of the lecture today is just to make a summary of what we have been doing for this during this semester. So it's the last course, meaning that it's also the time where you should have more and more questions. So I will be there to answer questions just after I have finished the short summary. Okay, so and do not hesitate to ask me questions, because the next time you will see me, then it will be at the exam, and then it will be me who is going to ask questions. Okay, so the short summary is the following. So we have been studying industrial processes in which we have been able to define or to look at the energy efficiency by first looking at the process itself, so how the process is converting raw materials into products and services, understanding what is the role of energy in each of the process unit operations, defining the need of this energy by applying mass and energy balances, from there deducing what are the hot and the cold streams in a system, to finally be able to understand the energy that we buy in order to supply the energy that is needed for making the process. And we have been looking at the whole system, the system as a whole, understanding where the energy will be acting and useful. So we have been able to define the flows of energy in the system, so what is needed in terms of heating, in terms of cooling, in terms of power for driving unit operations there. And then we have been able to define the streams to be heated and the streams to be cooled down. That would then they were allowing us to define where we can recover the heat. But at the same time, we have also realized that as soon as I have defined a stream to be heated, there was a stream from the utility system that is going to deliver this heat, which means a stream that is going to be a hot stream that is going to supply the heat for the cold streams in the process. Okay? So we have been able to make this analysis, and from there we have said, okay, how can we identify where is the most what is the most profitable way of doing heat recovery? And we have linked the heat recovery to a value which is the delta T minimum, which is the minimum temperature difference that is accepted in a heat exchanger, so that economically this heat exchanger will be acceptable, meaning that the value of the energy saved, which is the energy exchanged by the heat exchanger, is equal to the value of the investment. So I cannot go on both directions. If I'm increasing or decreasing the value of the delta T minimum, the extra amount invested in the area will not recover the extra amount of saved energy. So there is an optimum point, and this point is used as a reference for being able to calculate the composite curve, and calculate the maximum heat recovery in the system. So for doing this, we have seen that there was a method to calculate the integral of the heat that is available in all the streams that needs to be cooled down, and there is another integral that is giving us the amount of heat to be supplied. And by deciding the value of the delta T minimum for the whole system, we were able to identify what is the maximum heat recovery, and by balance, identify how much heat needs to be supplied from an external source and how much heat will be released from the process to the environment or to the cooling, the refrigeration here below. From this analysis, we have been able to identify the heat recovery that was allowing us to identify, divide the system into three subsystems: the heat sink, the heat source, and the refrigeration part below the ambient conditions. This analysis was also allowing us to identify what were the penalizing heat exchangers. And there are three types of penalizing heat exchangers. The one that are the cold utility that is used above the pinch, because above the pinch normally there is no need to use cold utility because all the heat of the hot streams is needed by the process streams, and below it's the reverse, so we have to avoid having hot utility used below the pinch because there is enough heat in the system to heat up all the cold streams with the heat that is available. And then we have also seen that there was a third type of heat exchanger, penalizing heat exchanger, that is the one that is taking a hot stream that is above the pinch and a cold stream that is below the pinch. And there are also hidden penalizing heat exchangers, which are the mixers. As soon as we have made this analysis, then on the one hand we have seen that we were able to design heat recovery heat exchanger networks, and we were able also to define the profile of the utility that needs to be, which defines in fact the temperature at which the heat has to be supplied or the heat that has to be removed out of the system, which then allows us to identify the heat recovery plus the possibility of integrating heat pumps, which is always taking the heat that is below the pinch and sending it back above the pinch. And afterwards, we have been able to, by studying cogeneration, we have been able to identify what were the possibility of doing cogeneration, meaning producing at the same time heat and electricity from resources. So the utility system integration was based on the heat cascade, and we were able to identify what were the optimal placement of both the combined heat and power production and the heat pumps. As soon as we have the list of the possible interactions, then what we have seen is that there was a possibility of making an evaluation about what is the best investment to be done. So what are the best flows to supply the energy to the process, and what are the related investment? And we have seen methods to evaluate the investment and to compare operating cost and investment cost. And we have been showing that there is a very nice method that is using mixed integer linear programming methods in order to select which are the best options, and once they are selected, to calculate to which extent each one of the subsystem has to be used to close the energy balance. So at the end we have a system like this one, where we have the heat recovery, the heat pumping, finally the waste heat that can still be converted into electricity to some extent, plus the waste management that can also be integrated, perhaps converting the waste into heat or into energy resources that can be used in convection systems that can at the end supply the energy that is needed, perhaps from biomass resources rather than from fossil resources. So this was the analysis that I have explained last week, so that at the end we are able to show that our system will be 100% driven by renewable energy, and that we will be able to claim very high efficiency in terms of exergy efficiency as well. The exergy analysis was used in order to verify that the list of our the systems that we are proposing were the best one. For example, like in the case that I have explained, where you have an integration of cogeneration plus mechanical vapor recompression plus heat pumping. We have seen that the exergy analysis was helping us identifying if we have made the right choices in the utility system, trying to identify where there are exergy losses. The exergy losses can be at the level of the heat recovery or the heat exchange, but they can also be at the level of the efficiency of the different elements in the system. So you have been doing an exergy analysis of a refrigeration cycle, for example, where you have seen that there are losses in the heat exchange, losses in the compressor, losses in the expansion valves. Okay, from this we have been also looking at the design of the heat exchanger network, mainly applying the pinch design method, where that is based on feasibility rules plus heuristic rules. Something that I have not mentioned in the course is that there is also the possibility of applying mixed integer linear programming models to decide who is connected with who. But at the end, the two systems results into a heat exchanger network design, and we know that this one needs to be optimized. So it means that the delta T minimum that is applied to each of the heat exchanger in the heat exchanger network design needs to be optimized, so that at the end we arrive at the best solutions in terms of when we do a thermoeconomic evaluation. At the end, we have a method that allows you to look at the way the energy is needed, and afterwards the way the energy is supplied to an energy system, being a process or, in fact, a city or a big vessel in a boat. Okay, which integrates not only the heat recovery but also the energy conversion and also the water usage and the waste usage. So it's a systematic method that allows you to go towards solutions, and this method can be applied in a systematic way to identify what can be done. And there is this dichotomy between a targeting state that is showing you up to where we can go, and a synthesis step that is going to say how to reach it. So it's the maximum heat recovery and heat exchanger network design, which allows us finally to do a techno-economic evaluation of the different solutions, identifying the investment that is needed for each of the options that we are proposing, which is at the end a very nice tool for doing the engineering. You have applied this to a project, and the goal of the project was to show how to apply the methods, facing the difficulties of applying the theory, and perhaps also learning how to be pragmatic when we have to solve a problem. So it's not because the theory tells you that the optimum is 10.222111661 that you have to use this value. You can also decide by yourself that 10 is a reasonable value for doing the calculations, because you do it by knowing. You will have to write a report that needs to be clear and concise, so the assistants will not have to spend a lot of hours to read your report. They have to go to the point, and the report has to be like if you are reporting for in a company. Okay? Clear, concise, and going directly to the point, but allowing the person who is reading the report to understand what you have done. Okay, and be convinced. The guidelines can be found on our website. So just giving you some hints on how to write a report. The report is needed to come to the exam, so there is a deadline. It is the 21 or the 20 of January at 33:59 for the Swiss people. If you send it on the next Monday morning, I will not complain. Okay, and you have to forget about this line here. It's just an indication, so there will be no waiting. Okay, so the project is needed, and the understanding of what you have made in the project is mandatory. Okay, because it will be used for the exam. The exam is going to happen in the following way. The exam is 20 minutes of interrogation. And those 20 minutes are going to start with 3 minutes where you are going to present a poster that is summarizing what you have done for the project. Okay? So 3 minutes to make the presentation. If you take more, after a certain time I will stop you, but 3 minutes means that there are 17 remaining minutes to answer questions. So if you take more time, then you will have less time to answer questions. Okay? The reason why I'm using this poster as a basis for the exam is the following. You will enter in the room by being really concentrated on the 3 minutes presentation. And again, what I'm saying is that this poster is summarizing how you have applied theory to solve a problem. Okay? So it means that a priori, the 3 minutes is a complete recap of all the questions that I'm going, all the subjects that will be followed during the exam. So it's a very nice way to be really highly concentrated for the exam. And then afterwards, I will ask questions, and I'm going to show you in a minute how I'm going to do it. The poster has to be presented the day before the exam, and the reason why I'm saying this is that the poster is personal, okay, and has to be used as a hint for you to have in front of you all what you need to know to when you do when you have to pass the exam, okay. And this is the reason why we ask you to post the poster the day before, because then it means that it's really the way to make the summary of the course. The design is left to you. It has to be A0 poster that will be displayed on a big screen on a television, and then you will be able to show things on the television. Okay, so it means that you can use it as a way to, as a basis when you will be answering my questions. Okay, so what is supposed to be there is a summary of how you have applied, of the method that you have applied to solve the problem. And I do not need a lot of text in it, so it's better to have key points. Okay. The exam, my goal with the exam is not to verify that you know exactly why there is this decimal in the results. I want to be sure that you understand what you have done. What does it mean when I'm saying this is that the report might have errors. You can even come to the exam and say, oh, by the way, I realized yesterday by preparing my presentation that there was a big error there, and I can explain you why. Okay, and this will be as valid as a perfect report which has no error. Okay, and it might also happen that my assistant, by reading the report, will say, "Oh, look, they have made an error there," and that I will ask you, "Can you explain why?" You have done it like this rather than like this, because I consider that this is not correct. And if you are able to explain, there is no penalty of having made an error. Okay? So I'm not looking at the numerical details. I want to be sure that you know how to apply the theory. Okay, so it means that you will have, well, I'm just using one example of one student of last year that is one kind of poster that is shown here. So what is important here is that it is explaining more or less what has been done, okay, with key points, with a graph. In this case, the student has not used a lot of details in giving formulas, okay? But in 3 minutes, the student was able to explain what has been done. So we have been looking at the processes, we have been looking at the calculating the delta T minimum, the pinch that represents the etc. Okay? Then when after 3 minutes she has just explained this, and I have been asking questions. So can you explain me what is the meaning of this curve? Okay? And you can see that if I'm asking what is the meaning of this curve, then she is going to tell me, okay, but for this I had to start with this, and then I have calculated composite curve, and this curve is the heat cascade. Of course, you cannot explain it only on this, so you will have a whiteboard where you can write things also to explain what it means. So, for example, how you have been able to plot this curve. Okay, and then I will ask you, so what is the meaning of this? So why do you write this? Okay, and then I will ask, how do you estimate the investment cost? But perhaps I will not ask you how do you estimate the investment cost of this heat exchanger here, but I will ask you how did you estimate the cost of this, I think here, the cogeneration engine. Okay? And it's possible that I will not start with this question, but perhaps with this one. Okay? So, and I will travel over all the subjects. So, and there will be someone who is the expert who is going to just look at the answers you give, and so he's going to take care of the fact that I have asked enough questions, so that I have not spent 10 minutes on the delta T minimum and not answering something else. And then he's going to look at the list of questions, and for each question there will be 3 stages. Passed without help, passed with help, or not passed. So it means that it might happen that something you do not know something, okay? Then if I realize that even if I'm helping you that you do not answer the question, then I have to jump to the next one, and I'm not going to wait until you perhaps find one day the answer. So I will ask you, okay, you do not remember, okay, can I move to the next question? Okay, I'm always trying to be fair, and there will be, so the assistant will be there, and one expert who is just taking notes, so he's not asking questions, just taking notes about your answers, which means that at the end I can, if you come to me afterwards at the exam, I can show you what the reason why you have obtained this grade or another one. So during the 20 minutes, I'm just asking questions, not taking notes for myself in terms of grades. That's the experts who are doing it, and then afterwards we do a recap after 4 or 5 students to decide which what are the grades. Okay. So not to forget, so I think that the doodle is already filled for all the exams. Francesca? You have all the students? Okay, so don't forget to verify that you know when you have to come to the exam. For writing the report, so there is a delivery date, which is the January 20 at 33:59. Okay, this time. Okay, So that you let the assistant have the time to evaluate the report. Afterwards, you have to prepare the poster. Don't forget to use keywords and graphical explanations, and don't forget to use the poster as a way for you to have a structure of the course in mind. Okay, and then the last element is that the course comes with a list of questions, which is the list of questions that I'm asking at the exam. Okay. So it means that no excuse of being surprised by one of my questions because I know that the questions are there. Okay? So no excuse. So, and in order to help you, I have even added in this specific goals for each of the questions, you have 5 dots here. Okay? If you think that you will be successful in answering the question, make the 5 dots black. Okay. If you think that you are not really at ease, then you leave it with 3, for example, and then once you have reached the end of the lecture notes, you can go back and then you see what remains to be well understood. I have the impression that, and I will add a if to it, if you have planned your exam, okay, so it means that you start learning soon enough, that my exam is impossible to miss. Okay? You have all the tools, those are all the questions, and I can guarantee that I'm asking all those questions. There are let's say, there are no hidden questions that could appear. It's possible that there is a little bit more than the minimum required, so it's not guaranteed that I will ask all the questions, but I can guarantee that if you are able to answer those questions, there will be no problem for you for the exam. Okay? And also another element that is important, don't be afraid if there is a situation where you cannot answer. Okay, it's not a drama. Okay, I will first try to help you, and there will be a lot of questions. So even if there are questions that you are not able to answer, it doesn't mean that everything is ended. I will jump to another subject. Okay, there are a list of subjects, and I will try to be convinced about your level of understanding of the whole course. That means that don't be afraid if I'm starting from the wrong side for you. Doesn't mean that everything is lost. Okay, I will try always to find where I have to start if I realize that something is not going right. Okay, be prepared on the poster, because the poster is really the trick to be ready for the exam. So if you are able to explain me in 3 minutes what you have done in the project, in terms of which kind of theory you have applied to solve the problem, then it will be really easy for you. And the exams that I prefer is when you ask the questions ask the questions and give the answer. And this can be done, for example, you can say, oh, and there we have decided to apply, to assume a delta T minimum. The delta T minimum is ta 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 ta. And when I have to calculate the investment, I'll do it like this. Okay? The experts are smart enough to realize that it is like if I'm asking questions without your help. Okay? So it means that an exam can be done only by yourself if you want. Okay, and the last dimensions perhaps is that when we reach the end, when we reach the time I'm going to ask more and more and more complex questions at a certain time. So, but it will be a good sign for you, because if I'm asking complex questions, it means that you are reaching the 6, right? And it's not impossible to have 6. Okay? Do you have questions for the exam? Yeah.
Are we allowed to bring notes for the presentation?
For the presentation, yes, but it's only 3 minutes.
Yeah, okay.
So, and I can tell you, I had the experience of someone who had prepared a lot of notes. Okay, so he did arrive at the exam, and then I was asking questions, and then he was going like this, trying to, but it doesn't show that you are mastering the subject.
Yeah.
Okay, but of course, if you need to have some hints that is not on the poster,
it's not forbidden.
It's not forbidden for sure. But you have to know that the time is limited. Okay, and I have a lot of exams per day. Okay, so it means that if at a certain time I will be under pressure to finish the exam, because the next one is waiting for the next in the next slot. Okay, so it means that if you are not efficient, then you will be disappointed as well. Okay.